Hi there everyone, my name is Dominique Intriago. I'm a part of Dr. G's Chemistry 2 laboratory class, and today I'm going to be talking about experiment 6, the order of reaction of potassium permanganate and oxalic acid. So for the materials and chemicals that we're going to be using today, we have oxalic acid, or potassium permanganate, distilled water, beakers, test tubes, Erlenmeyer flasks, hot plate, burette and burette clamp, thermometer, and our glass stirring rod. In part A, we saw the effect of concentration. At first, we used a burette and poured 5.00 milliliters of oxalic acid and 6.00 milliliters of distilled water in a 50 milliliter Erlenmeyer flask, and then we mixed the solution by shaking the flask. In step 2, we poured 1.00 milliliters of potassium permanganate in the Erlenmeyer flask with the oxalic acid and water and started a timer. In step 3, once the red color of the permanganate disappeared, we stopped the timer because this will be the most reliable endpoint. On step 4, we recorded the time in seconds. And on step 5, we repeated the experiment 2 more times using the different quantities listed for experiment 2 and 3. For part B, we saw the effective temperature. In step 1, we poured oxalic acid and water in one test tube and potassium permanganate in another test tube. This is for experiment 4. On step 2, we located the test tubes in the hot water bath with a temperature of 10 degrees Celsius higher than room temperature. On step 3, after 10 minutes, we transferred the oxalic acid into the potassium permanganate test tube, and we mixed them with a glass stirring rod and started a timer. And then we stopped the timer when the red color disappeared and gave a yellow color. On step 4, we recorded the time in seconds. On step 5, we repeated the experiment 2 more times. And then for experiment 5, we have to repeat all the steps from experiment 4, but the only thing that changed is that now we were using 20 degrees Celsius higher than the room temperature. And now that I have explained all the experiment parts, I want to show some of the math, specifically how to calculate the concentrations. So we have our concentration of potassium permanganate, which is going to be equal to the volume of potassium permanganate divided by the total volume of reaction times the molarity of potassium permanganate. And then we have the concentration of oxalic acid, which is going to be equal to the volume of oxalic acid divided by the total volume of the reaction times the molarity of oxalic acid. Our first example, we see the concentration of potassium permanganate, which is going to be equal to 2.0 milliliters of potassium permanganate divided by 12 milliliters of the total volume reaction. This is including the water, the acid, and the permanganate, times 0.130 molarity potassium permanganate, which was the given concentration, given molarity. And then the concentration of potassium permanganate equaled 0.16666666667 times 0.130 molarity potassium permanganate. And after that, we got a concentration of 0.0217 of potassium permanganate. Now for example of the concentration of oxalic acid, we have 10.0 milliliters of oxalic acid divided by 12 milliliters total volume reaction times 0.755 molarity oxalic acid. And after that, we did the math, and our concentration ended up being 0.629 And thank you so much for watching.